Good morning, students. So in our last class, we complete up to question number 6 from the exercise 6.2 chapter triangles. As noted. So here another 4 questions are remain. So today here we have to discuss the question number 7. And if you see the question number 7 is given here using theorem 6.1. So first of all, using theorem 6.1, that means what? The Thales theorem, or also we can say the basic proportionality theorem. So with the help of this Thales theorem, we have to prove here what? A line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So that means here, what is the meaning of this statement or this line? First of all, if you see the diagram, with the help of diagram, it is more comfortable to understand this one. So first of all, if we consider a triangle here, suppose this one is a triangle here we consider, first of all, and this triangle is here A, B and C. For example, if we consider, is it clear? And now here, according to your question given, a line drawn through the midpoint of one side of a triangle. That means if any one side, suppose if we consider the side is here and the midpoint is here we consider, suppose this point is here we consider P. Is it clear? So one side of a triangle parallel to the another side and bisects the third side. That means here, for example, through this P, if we draw a line, suppose the line intersect the AC at this place. Suppose if we denote this point is Q. Clear? According to your question, this P is given here midpoint. Is it clear? This P is given here according to our question given midpoint, as well as this PQ line is parallel to another side. That means these two are also given parallel, you see here. That means this PQ and BC are parallel given to us. And now here what we need to prove? Another side bisect the third side. That means first side is this one, second side is this one, and the final is, which one is the third side? That means bisect the third side. That means we need to prove this Q is the midpoint. That is the question. That is the meaning of this statement, isn't it? So here at first, at one side midpoint is given, and through this point if we draw a line, this line is parallel to the second side, this one BC. And now here what we need to prove? The third side bisect the third side. That means here, if this Q is the midpoint, then this AC bisect or separate into two equal parts. So that means what we need to prove? We need to prove Q is the midpoint here. This one is the diagram and this one is the meaning here. Let's see how can we solve this one. And here at first given using theorem 6.1, that means with the help of basic proportionality theorem or Thales theorem, we have to prove this one. So at first what you have to write? So when we have to start the solution, at first we have to consider the triangle here. So that's why here you have to write consider the given figure, or you can write let us consider a figure here. In this also you can write here consider a figure. So in this way you have to write consider a figure in which now here you see in which, first of all, where we consider the midpoint P. So that's why you have to write in which AB, this one is line segment, consider a figure in which AB line segment drawn through the midpoint. AB line segment drawn through the midpoint, and the midpoint is which one? Drawn through the midpoint. Midpoint is here we consider P. So that's why here you have to write in which AB line segment drawn through the midpoint. So that's why here you have to write drawn through the midpoint P. Is it clear? So midpoint is here we consider midpoint P. So here, or you can write in this also, line segments. Directly you can write here in this also. Consider a figure in which PQ line segment. In this way, if you write, it is more comfortable. PQ line segment drawn through the midpoint P of side AB. Is it clear now? So what we write here, consider a figure in which PQ line segment drawn through the midpoint P of side AB. Is it clear? Such that the condition is what? When we draw the line segment PQ here, AB, comma, such that the condition is given here, PQ parallel to BC already given. So that's why here you have to write this one is PQ parallel to BC. In bracket you can write here, this one is given. This one is the first line. So here first of all what we have done, we draw a PQ segment. Is it clear? This one is PQ, and which one is P is the midpoint of side AB, and given PQ is parallel to BC. So now here, if PQ is parallel to BC, now in this case you see, if PQ parallel to BC, then what we can write here? Using the Thales theorem, with the help of Thales theorem, what we can write? The other two sides are divided in the same ratio. According to our Thales theorem, we know this one. So that's why other two sides are these two. Here we consider, that's why we have to write by using, next you write, by using Thales theorem, we obtain, by using Thales theorem, we obtain what we can write here? The other two sides are divided in the same ratio. That means AP by PB. So that's why here we have to write this one is AP by PB is equal with AQ by, this one we write here AQ by QC. With the help of Thales theorem, we write this one. Now one thing you see here, since P is the midpoint, is not it? If P is the midpoint, then the distance of AP and PB are same, is not it? So that's why in bracket you have to write, since P is the midpoint, so therefore what we write here, the length of AP is equal with PB. So in bracket you have to write in this way, since P is the midpoint, so therefore AP is equal with PB. So that means in place of PB also we can write, in place of PB what we can write here, also we can write AP, because P is the midpoint. So that's why here we have to write this one is AP by AP equals with AQ by QC. Clear? So now I write here AP cancel. So what will remain here? 1 equals to AQ by QC. Or this implies here we get 1 equals to AQ by QC. And if you cross multiply this QC, so that's why here you get QC equal to AQ. So the distance of QC and AQ are equal. From this calculation, what we get here, QC is equal with AQ. So where is QC? QC is this one, AQ is this one. If these two lengths are equal, then what we can say? Q is the midpoint. So therefore, from here we can write therefore, or also you can write hence Q is the midpoint. So therefore, Q is the midpoint. Is it clear? Therefore, Q is the midpoint. Is not it? And what we need to prove here? So here another side bisects the third side. Is not it? So that means bisect the third side means which one? AC. So here already we prove Q is the midpoint. So if Q is the midpoint, from here what we can say? Hence this PQ line segment bisect the third side. In this way we can prove. Finally you have to write down the conclusion. What you have to write? Hence this PQ line segment bisect the third side, and the third side is which one? AC. And this one is our proof. I think all of you understood this one. So in our next class, we have to continue this exercise, and in our next class, we discuss the question number 8. Is it clear? Okay. Thank you.